Okay. So, hopefully you guys have the ability. Am I showing full screen now? Is that,
No.
on? Ah, it wants to share this on my secondary screen, and I only shared. Let me try and stop again. Share one more time. Share. I will
So
share.
if you have questions, just put them in the chat.
All right. Uh,
So it's
how
kind of,
how about now?
yeah, but it's really skinny and vertical.
Let me sharing. So you're
The other
seeing
way
my
was better.
you're seeing my secondary screen, which when I do slideshow, that's what it wants to do. So let me stop sharing. I'm going to share one more time. We may have to live with this as big as it gets.
That's fine.
All right, so
That
let's
looked
do
good.
that. Okay. All right, and let me get rid of the show ribbon. Okay, so there we go. All right, so agents to queries. We talked about this. Um, what I will say is, if you noticed in the upcoming stuff, vectors is the subject of a future as well as a past presentation to this group. So I'm not going to spend a huge amount of time on that. It kind of has its place, but I won't dig nearly as deep as I'm sure you will in those other sessions. But let's get started here. So we'll go through who I am really quickly. I'm going to talk about the AI framework and talk about the pace of change and how quickly things are moving with this within the AI framework and how that interacts with SQL Server, MCP servers, RAG, custom integrations directly against that. We're going to use all of those things with a demo around a recommendation engine that I've been building, and that recommendation happens to be basically around cost optimization of an Azure SQL database instance. So hopefully we're doing everything Azure SQL database, and we'll go from there. But let's get started. So my story. And again, I did this presentation for the first time for the in-person portion of the New England SQL Users Group back in December. So that was 2025. Uh, Even in this short amount of time, these 6 months, things have changed. I'll call out semantic kernel has now been kind of rolled into Microsoft Agentic Framework v1.0, didn't release until 2026. Um, and there's just been a lot of stuff that has been going on in terms of the trends within the AI space. So I've tried to kind of update the presentation that I did that day to reflect some of that stuff. But getting back to my story, I started out as an Excel guy, really Lotus 1, 2, 3. I'm that old. Um, and from there, my history has been just a matter of bringing on additional tools to be able to solve business problems. So my mindset is always a business problem focus and kind of how do we use data to be able to solve those business problems, analyze them, and kind of get to a better outcome. Um, and I've kind of kept up with all these different things. And of course, over the course of the last 2 years, the big piece of that has been AI. I've gotten into LangChain, done a little bit with semantic kernel and Microsoft agentic framework, but agent framework, but LangChain is really where I've spent most of my time, and that's probably what we'll look at. Um, and with my current consulting company, I've been with them for 14 years. Been doing basically Azure implementations since Azure was a thing, uh, from its very earliest phases. We're a heavily Microsoft shop. We have a partnership. We're one of, I think, 60 higher level partners with Microsoft for around data implementations, and I'm part of that group. All right, let's talk about the pace of change and the agent that we're going to look at in terms of our piece here. So we talk about AI. Things kicked off probably in November 2022 when ChatGPT had its first public release and became kind of viral, and people started to pick this stuff up. A lot of different things happened over the course of time in those last 3 years. My personal history, I started playing with this in February 2025 and made kind of my first basic agent, doing some very simple things just to try and understand how all this stuff worked. It was a little side project on my side of things. I was still doing Azure implementations by day and just trying to figure this stuff out and by night. I got to a point where I started to want to talk about this more internally. I built some specialized agents based upon some releases of tools that happened at FabCon back in March 2025, and did a larger presentation around a multi-agent recommendation engine in September of 2025. Tweaked that to be the SQL-focused piece that the New England SQL user group saw in December, and now I'm here. So this is kind of how we got here, and how AI in general is changing quite a bit. So let's talk through some of this stuff and how it's going to be relevant to SQL Server. All right. So over the course of again the past 6+ months or so, the last slide that I had with this was a little different. It was talking about kind of capabilities of individual models and the increase in context window sizes. And the reality is, over the course of the last six or 8 months, that's shifted. And instead of just agents, or excuse me, models with bigger context windows, we now are worrying more about context engineering, right? So instead of giving it a million lines of text to be able to go through, the challenge now is to try and get the right set of data so that it has the ability to kind of come to the answer that we're aiming at. So we're trying to that approach has kind of changed in how we in how we go about doing this. At the same time, through the second half of 2025 and into 2026, MCP is becoming more and more of a standard within the space. It basically allows us to give an LLM tools to be able to do certain tasks. So, and we're going to go through 2 different MCP servers that we have in place. One, the standard SQL one, where basically you can use free text and have it try to generate dynamic queries on the fly, which is good for some things, not good for really complex things that professionals, like probably a lot of you guys, are building on a regular basis. But it has some functionality around that. And then we have a second MCP server, which is a little bit more purpose-driven, that's interacting with SQL Server that I'll walk through. And then on the framework side, above all of this, we now have more and more focus on how agents talk to each other with A to A, and then what orchestration kind of lies above that with Microsoft Agent Framework. LangGraph is in that space as well, whereas Microsoft's a little bit more enterprise-focused. LangGraph is a little bit more, I'll call it process-focused. We'll talk a little bit about that too. And then within SQL Server, so we know about the native vector type that was released. You can also create external models and embeddings and pull stuff directly from T-SQL. Saw a great demo of this, which this is not something I'm going to show, but a great demo of this when I was at FabCon 2026, around kind of how you can use some of this stuff against text that may exist within your larger database. That said, I don't know if this is going to end up being the place where we're doing a lot of the individual pieces that are here, but there is a place for it potentially for example, data quality, recommendation generation off of a set of data, which we're going to talk through, and a couple other things. We'll talk through the SQL MCP server, which I talked about earlier, Fabric data agents, and then at Build 2026, Microsoft talked about agentic fabric and databases designed for AP apps specifically. And that's another thing that I'll talk about, is the process of actually designing some of our tables not just for optimization of performance and maximization of kind of how we have the entity modeling correct for not storing data twice within, for example, a warehouse layer, is a little bit different now. And I think the thought process of how we optimize, especially naming conventions, for an agent that's going to take a look at that database, I think that that's something that we should be thinking about more. It's not something I'm covering deeply in this presentation, but I just want to bring that up because I feel like that's an important thing that we should be considering as we go forward and build and continue to build SQL database-based solutions. All right. Moving on, let's talk about the recommendation engine. So with all these pieces and how SQL can interact with these pieces, we're building this, we're trying to build this recommendation engine. So we're going to try and have that recommendation do research, and I'll show how it can pull data from SQL Server to do that. It can pull data from the web. We can create RAG vectors within that. We're going to contextualize all the information that we have around that, synthesize it, and try and get kind of an overall picture of what's going on. And then eventually we're going to get to a recommendation phase. So here's the task that I've set for our agent today. So what we're going to do is we're going to analyze the current operation of one specific Azure SQL database instance. We're going to try and understand the configuration and orchestration. Are we meeting business requirements? Basically, is performance where it needs to be? But we also want to think about cost optimization and we want to bring that into account. So when we think about the pieces of information that are going to be relevant to this overall analysis process, we've got a bunch of different information that's available, right? So we've got cost information. So the solution that I'm going to show this as a part of is actually an Azure focused cloud cost optimization and management platform that we run internally at my consulting firm. And this is basically a tool set that I'm trying to add to that to be able to look at these individual databases. So we've got cost data, which already exists in that database. For the individual Azure SQL database, we can get the CPU over time, the log IO, the memory IO, and various other metrics from management APIs to be able to get context on what's the performance of this thing over the course of a normal day. The resource activity log and the resource change log. So if people are changing configuration or doing other things to the database over the course of a day on a regularly scheduled basis, we're going to have visibility to that. So one of the big things that historically we've done, less with Azure SQL Database, but in a lot of cases with the Synapse Analytics databases, so the SQL Data Warehouse instances that are much larger. In a lot of cases, we'll run a script where we scale that instance up during data processing and then scale it down to a level that can support the ad hoc activity that it'll have during the rest of the normal day. And we'll be able to get clarity around what's happening with that. We can see the history associated with that, so we can know when we're suggesting alternatives for how to optimize this thing, whether that's already being done, and that kind of thing. The Azure retail pricing, that's going to be important to understand not just what the cost is right now, but options around savings plans or reservations for individual instances. So if you pay to have this up at a certain level for 24 hours in a day, and you make a commitment up front for 1 year at that level or 3 years at that level, you're going to pay a discounted price. And if we think about kind of what the activity level is, and if that fits into that, that's another piece that would be a consideration for how do we optimize cost around this, given the level of activity that we specifically have. In addition to that, of course, Microsoft optimization best practices, we can go out to the web and get lots of different pieces there. And then we also have our own internal people have our own ways of specifically doing best practices that are things that we may look for. We can put that into a Word document and support that with RAG implementation to be able to layer all of these different pieces of information into a deeper analysis of what the possibility of optimization is for a specific thing. The other piece that I'll layer in here, actually, never mind. I think I'm good. All right. So this is kind of what we're going to aim at. Oh yeah, that's right. That's the one other thing. The other thing that can be useful for this and can be really important for this is the ability to add context around an individual resource. So Azure, in the metrics that we have, may have no idea whether an Azure SQL Server instance is a prod instance or is a dev instance or is something else. And that can determine the suggestions that it will make. So, for example, in a serverless implementation, if you've got a 1 minute time to spin back up, if it goes into a pause state in a production instance, that may not be acceptable for an end user situation. So we also need a mechanism to be able to bring in a person's feedback or context around an asset that we're looking at. All right, so that's kind of context of kind of what we're aiming at. Now let's talk about how we're going to go about doing this. All right, so first things first, got a simple MCP server for a SQL use case, right? So Microsoft does have their official SQL Server MCP instance. So I've hooked into that to be able to kind of show you a specific example there. What we're going to walk through is I'm going to do a demo of this live, hopefully, and we'll walk through kind of the question that we're going to ask it, and then we'll walk through. This is a screenshot from Langsmith, if any of you are familiar with that kind of walks through and shows you what specifically is happening when that LLM call is going through and how that's working. So we'll walk through that piece. So we'll have both the MCP server on a base SQL Server case, and then we'll also have a separate MCP server for some of our deeper specific purpose around pulling in the metrics that we talked about previously and a couple other things. Well, let's start with this example, right? So if I take this, now we already have some of the SQL metrics that are here put into a database, although we may need to update them. I have a historical operational context description and when the last time we did that available within this database table, and I may want to look at that. Now I've made if I kind of productionalize this, there's no way that I would end up doing this with a number that's here, but I just wanted to kind of create a scoped example for you guys' purpose. So I'm going to steal this as a prompt that I'm going to layer into this. I'm going to walk through this and close that. All right, and I'm going to close this, and I'm actually going to start a brand new terminal. Okay, so here is our front end. So this is basically a chat-based front end that this agent is using that has some of these capabilities built in. So when I run this on, so we've got Langsmith tracing enabled. I'll show you what that looks like previously. We've got a name associated with it. I've got two different MCP servers that I'm starting up. So the standard, it's weird. The standard SQL MCP server, and then the Azure Optimization MCP server. We've got those connected. We've got a bunch of tools that are available with that. So the SQL MCP tools are a little simpler. The Azure Optimization, we've got a few more that are there. These are all tools that are going to be available to this AI instance to be able to do what it wants to. All right, and this is kind of an example, and we've got the front end here that's showing us some example workflows. So, and the first one kind of here is very similar. This is what I just copy it from here because this is going to do the same thing anyway. I'll throw this in here, and it is going to run that out. And of course, it's refreshing instead of getting the operational context. It should be getting the operational context. But basically, and let me actually show you this too. So if I get back to this, we've got a couple different things going on. Within this table, I'm jumping ahead here. Unfilter this. Okay. So we have this relational database recommendation. Now, I talked about basically getting us recommendations around operational context. The operational context input field that I have here, if I wanted to go about saying this is a production database and the SLA on it is that responsiveness needs to be above X, or we expect this database to have once per week spike of activity that's 2x what the normal daily is, or any other context that we want to add so that the agent that we're using has additional information to make its recommendations around, I'd be able to kind of put that directly into the database here, and I'm going to have that automatically pull that in and be part of that. And then this is the last time that I ran it, and honestly, what I meant to do was this. So I can basically update this and then say I'm going to start with 0 operational context. So you can see that I'm not cheating and having something in there already. So we're gonna get to that here. And if I jump back here, this one, what I really want, let me go back to this, because this is the example that I really wanted. This should show me, should hopefully go quicker. All right, so this should show me, so this is the SQL MCP. It's going against that specific table, and you can see here that because I just set that, it's now showing me that the operational context associated with that is NA. So it is going out and kind of leveraging that specific piece, and you can interact with the larger SQL database this way. So if I'm asking questions with specific table names and specific fields, it's going to be able to, so it basically created its own query against this. And if I look back to here, and here's where we get to Langsmith, and I look at this, and I look at the most recent piece here, right? So here's the operational context, right? So when we made this call, right? Actually, sorry, here, this one. Get the operational context, and so this is what we just sent in, right? And it is looking at that. It found the specific table. It's then using a tool to come through this, and it's looking at the columns associated with that table, right? So it's looking at all the columns that exist within that specific table, and then it is creating its own SQL query based upon that with this to be able to return what I specifically asked for. So I asked for the operational context description and the last updated date, and there you go. So we've got that specific information available to myself. The other thing that you can notice here is with this, and I'll actually go up here. So with this implementation, with this agent, it knows all of the various tools that it has access to. So you're seeing all of the individual tools that it's going to pull, that it has the ability to pull from. This is a mix of the ones that are coming from the MCP server and custom ones that I've created that we're gonna use. So for example, we could get a list of all the tables, that describe an individual table. Those are probably from the standard ones and so forth. So we've got kind of that full set of tools at its disposal, and it's choosing based upon the description of each one of those tools, which one it should use, and then how it should go about doing that. So we get that information, and it can kind of answer that question. So that's the simplest example of kind of what it's doing to be able to get to the answer that I specifically want. Now, if I go back to here, and I actually also want to refresh my data. So basically, in this case, run down here and do this, okay? Now, in this case, I've built a standard or a specific tool, right? So let's see here. So this is the latest operational. Data's already been refreshed because we just did that previously. So we have that. They're going to be valid for 60 minutes. Let me go back and show you what that actually did. So if I come in here, I've got my SQL metrics here, right? So if I look at this, and I'm looking at, here's 1921, it's doing 7 days worth of data. It's a half an hour, once every half an hour, and I've got CPU percentage log, physical read write, number of sessions, APUs build, CPU limit. So we got kind of a lot of the different pieces that we want that are specific to our analysis in terms of optimization, right? So I can fill in the SQL metrics. I've got another table for my activity log data. I've got another table for my change log data. And I've got another table for my resource attributes, which I'm going to show this one too. This one's kind of important. And we're doing this for more than just this one. So I'm going to do where resource E equals 1921. And when you're typing in front of people, that's how it always goes. All right. So if I do this, you can see that this is a GPS Gen 5. My SKU, my capacity is 12, a maximum of 12 CPUs. And some of this other stuff is going to be relevant depending, and my minimum capacity is 1.5. We've got a 60-minute auto pause associated with it, maximum size of bytes in terms of this. So we've got kind of the pieces of information that are going to be a little bit different depending upon which specific database you're looking at. But we've now got kind of all the information from where we're starting from to be able to do our analysis, right? So if I come back here, we've got our analysis that's here, or excuse me, the source for this. Now, let me jump back to this for a little bit because I'm jumping around all over the place. So here's our MCP server. One other thing to note. So security, when you're using an MCP server, needs to be a big part of your thought process. As everybody knows with LLMs, they make decisions and they can go about doing things, and the access that you provide to that MCP is going to allow them to do what they want to try and do or not. So we should not be providing an LLM with owner access on a database because it literally could just delete the database, right? So we need to be very, very careful in terms of how we implement this kind of stuff, especially when we get into granular agents that do have the ability to perform actions. We want to think about scoping security to individual stored procedures or very, very well-scoped, narrowly defined areas of things that they can specifically do. So that's something that we need to think about, and we need to just consider when we're designing that stuff. All right, so let's jump to the RAG side of things. So we talked about bringing in all this research. The other piece that we have, let me talk to this. So hopefully you guys have heard of retrieval augmented generation before. Basically, this is taking a series of text data and putting it into a vector database so that you can do what's basically a similarity search. So you can see that it's a distance in terms of they're looking for things within the database in terms of its distance for what's being asked for to get an answer that will come back, right? So this is going to be talked about in much more depth in other sessions with this group, so I'm not going to dig into it in detail, but just as an example of what is possible with this, we do have within this actually two different optimizations here. Optimization is the schema associated with this, but you can see here the embeddings are based with the new vector data type, and we have KB guidance is actually associated with best practices around Azure SQL database, and KB guidance native, and I may have this backwards, is SQL Server managed instances on Azure, best practices there. So we have the ability to kind of leverage both of these. So if I take a look at this and I say, can you tell me top 5 best practices? This is for Azure SQL database. Okay. It's going to take that. It's going to take a look at that. This is within my optimization. It's using that specific RAG instance, and it's coming up with 5 best practices for optimizing SQL Server. So worrying about hybrid benefit, regular monthly reviews, serverless auto tier, that kind of stuff. And then I could do the same exact thing, and I could do for SQL Server managed instance, and it's going to do the same thing from that second MCP server that's there, or excuse me, tool on the vector instance that's there. Interesting. Something changed since the last time I tested this. That was working. I'm not sure why it's not right now. I don't know if a refresh screwed something up, but you get the general idea. So with this stuff, this is another layer of information that can be leveraged for the purposes of generating an overall recommendation. Okay, and if I come back to here, back to tracing, come back in here and look at this. Okay, so if I scroll down, I'm going to be able to see. That's the native vector search, but you can see this previous one. It called this. It's looking for the management. Oh, sorry, this is the one that I want. Here we go. Here's the tool. It's coming into this. It's looking at all these pieces, layering this stuff in, and then bringing back specific pieces of information that best align with the question that I'm asking. And you can kind of see the full history associated with that. All right, so let me jump forward. All right, so we talked about RAG a little bit. And again, August 12th is, I believe, the session with this group that's going to be talking specifically about vector search and RAG. So you won't want to miss that because you'll get a lot more detail than I just showed. All right, one other piece, which is this one is a little bit different, but I feel like it's important to layer this in because when we're talking about AI interacting with data that can exist within an Azure SQL data environment, Fabric data agents are becoming more and more important. They can live alongside MCP servers. They can be an agent within a larger agent, but Fabric data agents are specialized within the Fabric space. They work with semantic models, but they also have an interesting ability to combine data that may exist in a semantic model with other data sets that it has access to. And it actually has the ability to do cross source joining. So for example, semantic data model, of course, is basically, it's Azure Analysis Services, but the newer version of that, which is very different from a SQL table-based data piece. But if you give a Fabric data agent instructions as to a data set that's not in the semantic model, but can be joined to, that may be a SQL Server database instance that can be joined to via a key that exists within the semantic model, it can start to do some interesting additional analysis that it might not have otherwise had. Now, when it comes to this, I'm going to jump here, and I want to be here. You have the ability. So this is for our cloud cost optimization and management agent in our dev environment. We have basically instructions around how it should think about all the data that's in here, right? So this is guidance that we're giving to that agent when it's talking about that. So we can have basically the data that it's specifically trying to look at and information around that. We can have, there's a bunch of different tables that are here. We can also have examples of joins. Find that. So here's a query example pattern. So basically, if you needed to look outside of the semantic model to be able to join to other pieces, if you give it examples of how to do that, then you can start to get to some of that information. And it's going to talk about how to think about certain types of analysis as well, right? So you're giving it hints on how to go about doing analysis against your table. And this kind of stuff, again, I see the way that AI is going, this is going to become more and more important to have naming that's going to make sense to these individual agents, and then have instruction sets that are going to allow them to leverage that information to get to people that are interacting with it directly. Okay, so just something to consider. It's an important thing. A little bit outside the scope of what's in my recommendation agent, but I just wanted to make sure I didn't miss that. All right, let's go forward. All right, we have had internet, and I've been able to show all this stuff. So the last talked about this previously. Actually, I already showed that. I'm ahead of that, and we want to show the graph state and the synthesis and the summarization. So now, we talked about this earlier. We have all this information. These are a whole bunch of different pieces that we now need to bring together to be able to get the example of what we need. So, and this has to do with how LangChain and LangGraph work. So basically, in the back end, this is a Python application, but in the back end, they have the ability to gather sets of information. So we talked about the attribute information that's there, the SQL metrics of the important information that's there, and then so daily cost, we didn't even really cover the daily cost side of things, but that data is available to it as well. And then the combination of all this, once it kind of has that information available to it, it can start to do its decision-making process against that, its synthesis and its decision-making process. All right. So this, we ended up changing this a little bit, but the other way to think about this is when you're talking about, this is really a workflow, right? So if we're talking about, we want to optimize this, we should think about like the steps that it's looking at. So cost summary data, first step is this worth analyzing at all? I think when I was running this earlier, it was telling me that it's basically 5 cents an execution for looking at a specific database. If you've got a $5 instance, $5 a month instance of Azure SQL database that you can't get any smaller and you can't optimize, it's not going to be worth analyzing, and we should be skipping that, right? But then once we get there, I talked about the business context, and is this a prod server or is this something else? We're going to get the metrics, the attributes, and the events. We're going to look at the overall operational configuration and how things have been working, look for reservation options, look for current and alternative pricing, and then we have the ability to get to a final recommendation of pricing with configuration around all that. And then we can get that recommendation. Then a human is looking at that and saying, does this make sense? Should we make these changes to this specific resource? And then we have an output that is hopefully resulted in a better, more optimized piece. So when we're thinking about kind of what we're doing with SQL Server and all this stuff, thinking in terms of these processes is important and useful. All right, so the output, right? So this is, and I can take this output and I can save it to a database, or I can route it to a specific UI depending upon how I wanted to do it. This is a screenshot of what I've done, but let's actually do this here. And I'm going to analyze. Okay. So it's now trying to kind of take all this stuff, right? And this is going to take a little bit longer because it's going to take all that information, and it's going to try and get a sense for what this specifically should be. I was having some timeout issues on this earlier because I didn't want to spend so many tokens that it was going to bankrupt me, but hopefully this will go relatively fast. And maybe it's been a quiet group. I've just been talking. Hopefully I haven't put everyone to sleep. Have there been any questions in the chat window or anything yet while we wait for this to come out?
No questions yet.
Not yet. Okay. Are people finding this useful? Is this interesting? I hope.
Yes, I think they are.
Yeah, it is too much to take in, man.
It's dense. There's a lot to show in a very small amount of time. And actually what I could show you while we're waiting on this is watch this. So if I go back to my tracing, okay, and if I scroll down towards the bottom, the last couple things that it's doing here. All right, so it is trying to start a new analysis in terms of, looks like attributes. There was a problem with it. It's looking at the attributes. And so, for example, it's got all this. We've got all this information that's coming out. I am using a very old version of a model. I think I deployed this in April of 2025. Still using it because it's cheap, and I just haven't migrated it to the newer version because this is my demo environment, not really my real environment. And hopefully, still hanging in. But the goal of this, what this should do when we're done, is it should come back to here. Actually, not attributes. This one. SQL metrics. Not SQL metrics. This one. It should be overwriting this, unless my demo is going to fail. So what we're going to do is we'll overwrite this with a full implementation, or excuse me, description. This is a screenshot from, I think, the one that I had done back in December. I don't think I updated this screenshot yet around this, but it gives you an idea of the kinds of things that it's looking for. I think I've made the output have a little bit more structure and a little bit more detail around certain things because I've added in some pieces, but this gives you the idea. So with this, and actually let me show you one more thing as we're going here. Oh, timed out on me again. Let me show you one more thing though. But if I look at this, hopefully you guys aren't going to take a screenshot of this, but here's my demo resource ID, right? So I'm looking at this specific database in terms of the piece that we're trying to analyze, and I've got I can very easily, and I have in other implementations, basically parameterize this so I can pass in whatever database I want and do a whole set of this analysis. So if I go back to here, and I think about this, right? So if I go, and I think this was actually not SQL metrics, but here, if I run this one, you can see previously I had run this across 75 different databases that we're specifically using to get their individual pieces. And depending upon the type of database, the information that's available is different. But you can kind of get a sense for how this becomes a system that scales pretty easily to be able to do not just the analysis of this, but other types of things. So I can easily see this being a system where we have AI doing some kind of process and making some kind of a recommendation, writing that information out to a database so that can be acted on in batches or individually. Okay. Does that make sense?
There was a question, I don't know if I missed, you took
Sure.
that or not, but can we use local LLMs like Olama during development phase to save token cost?
Absolutely. So I do not have that implemented in this specific demo environment, but if I were to show you this VS code. And So this is what you're seeing here is a deeper example of some of the stuff that I've done, but in the agentic framework that that I'm working on along with other people in my company. What I want to show you is under Joshua System, I want docs and I want architecture, and then I want model tier. Where are you, model tier? Is it decisions? No. No. Model tier. Specifications. There it is. Model tier selection. Okay. So this is a little bit more advanced in terms of kind of some of the stuff that you can do, but basically when it comes to various individual models, right? Different models have different strengths, right? So if you've got a more complex AI system, you shouldn't be using one model for everything, right? So the framework that we've developed actually has different for kind of standard tasks, reasoning tasks, code-based stuff, governance stuff, orchestration stuff, and then budget really quick stuff. But we've also got a whole local free tier, right? And then I've also got a critic. So we want an alternative to be able to look at we want a different AI to kind of review the output of another one. But within local free tier, yeah, you can totally do Olama for local. I'm mixing that with an implementation against Azure AI Foundry. And I'm having basically the Olama, because it's a relatively simple task, it will actually choose which model it should use for the task depending upon the complexity of it. And then it will go down that path, right? And there's actually, even within Olama, there's different types of free tier stuff. You do need a computer that has enough memory, and if you have a graphics card, that helps a lot too. So there's definitely some performance limitations to be able to doing stuff locally, but free is 100% an option to be able to do some of this stuff. Make sense? All right. Close that. Let's try one more time. Yes. Try one. Okay. So the tool here I have for 180 seconds. I really should have given it more time than that. What really happened was I had it working fine, and then I started getting greedy and adding more tools to this, adding more data sources, and now it has more to analyze. So we'll see if that works. But I guess while we're hoping that works, is there any other questions? We've got about 10 minutes left, so we're right around what we were aiming at, I hope, or what I was aiming at. Does anyone have any specific questions around this? Thoughts, feedback even?
No, I don't see anything.
Yeah, Bill was just asking if the business problem you are analyzing was based on you being a consultant. So you're designing and proposing an Azure environment for one of your clients.
That's a fair question. So what I will say to that is it started that way. And we ended up building, I'll show you one other thing. This is something that my company actually does. And I actually built it. So if I go to that's my demo environment. Let's look at this. So we have a whole cloud cost management offering where we have the ability to look at and let me centric. So here we go. So we're looking at, this is just centric costs. We're barely into July. Let me go backwards and let me choose previous month. So we actually have a whole offering around doing analytics. But this is kind of the monitoring side of things. So the AI side of things becomes the recommendation. So this recommendation piece is actually Azure Advisor, but it gives you kind of an idea of, we have a whole structure around gathering this information so that we can monitor it. Now this is taking that to the next step to be able to do that. And this is an offering that we actually sell. that allow people to come in. Part of this is the access to the monitoring tool over time. Part of it is an initial assessment that kind of gives you recommendations for optimization to get your environment to where it should be. So Azure SQL database is only one data type. There's a lot more that's in here. So hopefully that answers your question. That's where this came from and the direction that it's what you're seeing is hopefully is in the process of becoming an enhancement to what we already have around this. Other questions?
Can all this be done strictly with an on-prem database instance, or also can it be extended to Postgres?
Postgres, no, I wouldn't see any problems with Postgres. It's just a connector. In fact, if I had to guess, I'd be willing to bet that there's an MCP server out there that's specific to Postgres that will abstract a lot of that away. So basically, there's just going to be a configuration in terms of the credentials, but then you could do the same thing with normalized text questions to be able to kind of create some of those queries. Yeah, there's no reason. Postgres is 100% possible. For on-prem, if you're running this agent locally and it has access to your on-prem piece, I want to say yes, but I haven't tried. I'm not confident enough to be sure on that one. I don't know. There's most things are in the cloud now, but I wouldn't think there shouldn't be a limiter to that, but I can't. I'm not 100% sure to be able to answer that question. Any other questions?
For a DBA with performance and infrastructure background, how do I interface to this, and why would I need to?
So as a DBA, I guess, so if you were to look at this, right? So it did actually come out. So here's complete off of this, and you can see it's a little bit more detailed now, right? So here's our resource configuration right now. So our current SKUs, minimum, auto pause delay, zone redundancy, right? So we do have zone redundant. That's giving us a 30% cost increase. If it's a dev server, we could not need that. So this is going to tell you largely around how to save cost, but it's also something that over time, as things change, you could have things that may not be noticeable to a DBA that's just kind of doing their work over the course of things, over the course of a month. If the average CPU has suddenly risen by 10% or 15%, it might you might be able to write an agent that looks for things like that to be able to help with monitoring of your overall environment and then optimization of your overall environment. If I'm being honest, the newer releases from Microsoft around Fabric IQ, they have a new concept of agents that is specifically focused on that type of thing, basically overseeing a changing data environment and then reacting to things that are changing that a person won't necessarily have to kind of look for that stuff on their own. They can kind of keep an eye on things and then raise alerts when necessary that aren't kind of rule-based, right? So you're going to have some things that you've got a rule and you get within, say, 90% of the maximum size on disk or something like that, and you're going to want to increase things. But if it's not rule-based and you're looking for more interesting patterns, you can start to have agents do some of that monitoring for you and the optimization work that's there. That makes sense? Other questions? All right. Did we drain the well at just the right time?
I think so.
Okay. All right. Again, my contact information is here. If you guys have questions or want to reach out to me directly about this stuff, feel free. And I appreciate all of your attention and the opportunity to speak for this group. And yeah, thanks very much. I hope everybody has a great rest of their week.
Thanks, Jeff. Thanks
Hey, Jeff,
for
thank you so much, man. This was really awesome. Yeah.
Yeah, good, very good presentation. I think we're going to get a lot of hits on people watching the video.
Hope so. I hope
Oh
so.
yeah, absolutely. Totally agree.
Okay.
I will reach out to you, Jeff. Can you stop the recording? Then we can continue this chat. Yeah.
Yep, I'm stopping. Wait, let's see. The transcript has been stopped. Hold on. I said to stop the. Here we go. Stopped recording.